Welcome back, everyone. In the last sections, we looked at how to describe data graphically. We looked at histograms, their distribution shape. We looked at some other types of graphs. In this section, we want to decide what would be a good numerical representative for a set of data. And what I mean by that is essentially picking one number that may or may not be in the data itself, but one number to serve as the best representative of the entire data set. And when what I'm describing when I say the best representative is actually known as a measure of center. And so when we get into this next section here, there are two big issues we want to tackle. The first is this issue of measure of center. If I have a set of data, what would a really good representative be for that set? And then the second thing we want to look at is this notion of variation. Here's some numbers, got some data. How spread out is the data? Are the individual values wildly different from each other? Are they pretty close together? Do they kind of gather around some single number? How do we quantify that? And that's known as variation. And so we're going to start here with measure of center. And what I'd like to do is start by appealing to your intuition, because I really think that you probably, even though I haven't defined exactly what I mean by a measure of center, you might have an idea just intuitively of what a good representative would be if you looked at a set of numbers. So suppose I had this set, and I'm going to, realistically, your data set would probably not be in any type of numeric order, but hey, I'm going to make my life easy here. So here's a set. If you had to pick a number that would best represent this set, I think some people might consider the average. And I said, oh, well, let's take the average. That's pretty standard fare. You have a set of numbers, let's find their average. And is that a good representative in this case? Well, let's see. Now in statistics, we don't use the word average. We use the word, actually, let's erase this. We use the word mean. But mean is just our word for average. And so I'm going to take those values, 1 plus 2 plus 4 plus 5 plus 7. We're going to divide all these by the number of values. There are 5 of them. And let's see what we got. So 3, 7, 12, 19. So we have 19 fifths. And we could reduce that if we want, or write it as a decimal rather. And when we do that, we get what? Well, 15 goes into 19, 3, that's 3 4/5. So 3.8. Does 3.8 seem like a good number to represent this set? Would this, in other words, would 3.8 sort of be the archetype for this set right here? And I think it would. I mean, it's not that far from 7 or 1. It's close to 4, which is in the middle. It's all good. Well, what if now we had this set of numbers? 1, 2, 4, 5. And then instead of 7, I don't know, let's say we have 99. Now, you might look at this 99 or this whole set and say one of these things is not like the other. It's absolutely correct. 99, that's way out there. That number does not look anything like the previous 4 numbers in this data set. Well, maybe a naive thought would be, well, let's just always use the mean. Well, let's see what we get when we compute the mean here, because it could turn out that this number is not the best representative. So 1 plus 2, we have 3, 7, 12. 12 plus 99 is 1, 11. All over our 5 numbers. So we have 111 over 5. which turns out to be, what, 22 1/5, so 22.2. Now, does 22.2 look like a good representative for this set of numbers? No, you've got this set down here, 1, 2, 4, 5. They're all kind of down near, between 1 and 5. And then you've got 99. 22.2 doesn't really represent anybody in this set. So that's a horrible choice. Instead, however, let's look at this number in the middle, the number 4. Notice that this outlier, if I change that outlier, if it were actually 6, the median would still be 4. If this were 1002, the median would still be 4. Median, or number middle, when they're ordered from least to greatest, is very resistant to outliers. If that last number becomes wildly different than the rest, it does nothing for the median. But look what it does for the mean, right? It used to be 7, now it's 99. It's wildly different. The mean does not have that resistance built in. So in this case, 4 would be the better representative, not the mean. And then we might also look at, I'm going to kind of sneak this over here because this one will be a little more obvious. What if I had this set of numbers? 3, 3, 3, 2, 3. Well, what would be the best representative here? Hopefully you're thinking 3, because almost all the numbers are 3. And of course, that's known as the mode. So in each of these cases, you see that a different type of number was the more appropriate choice for representing the data set. Sometimes the mean, sometimes the median, and sometimes the mode. Okay, so let's talk in more depth about what we mean by these. So a measure of center is just a value at the center of a data set. And of course, that value we refer to as a measure of center. There are 3 typical measures of center: mean, median, and mode. And then there's a 4th, the mid-range. Really not going to talk much about the mid-range. This is where most of our attention is going to come in, is in those 3 standard measures. I'm sure you've heard of them before. So what are they? Well, the mean is the sum of the data entries divided by the number of entries. Now, keep in mind, back earlier sections, we talked about samples and populations. If I have a group of numbers or data, that could be population data. I might actually have every single value in the population. In that case, my mean is a population mean, and it is denoted by this Greek letter mu. I'll say that again, mu. It's like a U with a M in the front, and it's pronounced M, or it's spelled rather M-U. That's for a population. Now, if I'm talking about a sample, I'm going to use the notation X bar, and literally it's an X with a bar on top, hence the name X bar. So mu refers to population mean, X bar refers to sample mean. The median is the value in the middle when a set of data is ordered from least to greatest. Now, it's possible for 2 values to occupy the center or the middle when the data is ordered. And if that's the case, then we just take the mean of those 2 middle values. And then finally, there is the mode, and that's just the number that occurs with the highest frequency. That last one I mentioned is mid-range, and it's essentially just the mean of the extreme values, right? Your maximum value plus your minimum value divided by 2. It's known as your mid-range. Again, not really going to talk much about this. We'll stick to those first 3, but might be worth mentioning just for your own knowledge, or might run into it again someday. All right, how do we round? Well, 1 more decimal place than present in the data. So if my data goes out to the ones place, like 21, then my rounding, if I were finding a mean and I had, I don't know, 19, whoops, I can't write, 19.2943, I'm going to call that 19.3, okay? If my data goes out to the 10th place, then my rounding, if I had a number like 0.2178, and round to the hundredths. That'll become 0.22. So the point here is that we're rounding to one more place than is present in our data. Okay, that's the rounding rule. Okay, so here's some data, and I want to find the four measures of center for this data, and I'm going to show you how to do this on Excel. So if you want to open up your spreadsheet, I'm going to go ahead and pause this for a moment, open up your spreadsheet and get that data in there. We will we'll crunch those numbers in Excel. All right, so I have entered these numbers into Excel. And what I'm going to do is go through and find those different measures of center. So the mean, after I made that big deal about saying that we refer to the average as the mean, Excel, so I'm going to type mean equals here. And I'm going to go to this next cell here. So I'm in D1. Excel calls the mean the average. So guess it's probably common vernacular, but we know that we're referring to the mean. So here's how this works. I tell Excel that I'm going to give it a formula, and I indicate that with an equal sign. So notice that I've got my cursor up here, and I'm going to give Excel a rule. I'm going to start with equals. And so when I write that equals, when I type that equal sign, Excel says, okay, I'm about to receive some rule. And then we can just type average and parentheses. And so now now Excel knows, okay, I'm computing an average or a mean, and then we need to tell it where the numbers are. And so you can do that a couple of ways. You can highlight, click on A1, and then holding the mouse key down, just drag down to the bottom. That's one way. Or you could actually type A1 colon A20. And you know you've got it all because that box highlights your data correspondingly. Close the parentheses, and there's our average, 4.16. So a mean of 4.16. All right. Now, the next thing we want to do is order this data from least to greatest, because we also want the median. And so the median, we're going to, if you remember, we go to Data and Sort. And so we can look. You might think, well, let's type median here. And then we've got 20 data values, right? And so that means that if you count them, right, we're going to have shared pair in the middle. So we'll have 1 through 9, right? And then 12 through 20, right? In each case here, we've got 9 values. 4, 5, 6, 7, 8, 9, and of course, 9 this way as well. So 10 and 11 occupy the middle. And so one way to do this is to just remember that, oh yeah, we're going to take the 2 middle values, so median equals parentheses, and then 3.9 plus 4.1 divided by 2. And that'll give me my median of 4, okay? And then the last one we want to look at is mode. Or not the last one, because we're going to do mid-range too, but mode. So for mode, I'm looking for whichever value occurs with the highest frequency. So when I look at this, it looks like we have 5.6s. We have 3 5.6s. So my mode is going to be 5.6, okay? All right. Now let's finally do mid-range. So I'm going to type mid-range equals, and now for the mid-range, I've already ordered my data, so I know what my least and largest values are, but I want to show you something else as well. Let's say we didn't order our data. I don't have to order it in order to reference the minimum and maximum values. So I'm going to type equals parentheses and then minimum or I'm going to start with the maximum, I guess. Maximum for max, parentheses, and then my list of values, A1 to A20, plus the minimum, so min, parentheses, the same list, A1 to A20, and then parentheses again. So what I have is the sum, and I want to divide that sum by 2. Okay, and there we go. Now, of course, you can do these by hand. You can use the scientific calculator, graphing calculator, but this is how you would do this on Excel, and I think at the end of the day, having some Excel skills translates to other areas as well. So there are the 4 measures of center for that particular set of data. Let's go back to our presentation here. All right, there's also something known as a weighted mean. And a weighted mean of a data set is where we take each x value and we weight it, corresponding formula. Now, this formula, let's see here. If you make sense of it, let's do that. So this symbol, this symbol here, that's an uppercase Greek sigma, and it just means sum. So when you see this numerator, you're going to, it's saying add each data value times its weight. So you've got these products of data value times weight, we're going to add them together. And then you divide by the weights. Now, pardon me, there are several places you would see a weighted mean. One that might be relevant to many people is GPA. If I took a, I don't know, a golf class, and then I took differential equations, differential equations is going to be a good 3 or 4 units. Golf is probably going to be 1 unit. So if I get an A in one of those classes, where do I want that A to be in order to have the most impact on my GPA? Well, I want it to be the course with the highest number of units. In other words, the course with the highest weight. So let's see what that looks like in the context of GPA. So you have a student take 6 classes over the course of an academic year. In the student's 2 3-unit courses, he earns an A and a B. In the 3 4-unit courses, 2 A's and a C, and a B in his 1 2-unit course. We're going to use the standard grade points 4 3 2 1 and compute this student's GPA. So remember that we have a sum of data values times weights divided by the sum of the weights. Well, what are our weights going to be here? Well, the weights are going to be the units. And the x's are going to be the grade points. Okay? So let's see what this GPA looks like. So we have a GPA equals. So I'm going to start with this numerator and just go in order here. 2 3-unit courses. Whoops, and I can't draw a straight line, so let's just try that again. But we have 2 3-unit courses. He earns an A and a B. So he has a grade point of 4 in a 3-unit course and a grade point of 3 in his second 3-unit course. So what you should see here is the A and B in the 3-unit courses. What's next? Well, let's see, 3 4-unit courses. So in the 4-unit courses, you got 2 A's. So that's an A for a 4-unit course, plus another A, so 4 grade points in a 4-unit course, and then a C. So we got 2 grade points in that 4-unit course. So here we have this sum is the A, and C in the 4-unit courses. And then finally, a B in his 1 2-unit course. So a B is 3 grade points and his 2-unit course. So that represents the B in the 2-unit course. And then of course we're going to take this and we're going to divide it by, well, let's see, 3 plus 3, those are his 2 3-unit courses. 4 plus 4 plus 4, those are his 3 4-unit courses. And then he had his 1 2-unit course. And when we compute all these things, let's just go ahead and do that. I'm going to do it off on the side here. I have a calculator that you can't see, but nonetheless. So 4 times 3 is 12, plus 9, plus 16, plus 16, plus 8, plus 6. We're going to divide that, and how many units? 3 plus 3 is 6, 10, 14, 18, 20. So 20 units the student took that year. And so we have a GPA of 3.35. And that's how your GPA is essentially computed. Okay. I would encourage you to go back and make sense of this, right? See where this formula is being used. A lot of times you see a formula like this, and especially when you start seeing Greek letters, and it starts to look intimidating. But keep in mind, a lot of what we do in mathematics is give efficient symbols, efficient notation for more wordy or longer phrased language. So, you know, the language of having to multiply each value by its weight, sum those, then divide by the sum of the weights, look how efficient this thing is. Of course, that's only going to matter if you understand what the symbols mean. So again, what I would encourage you to do is go back and look at this computation we did and see this formula being used, right? See the x times w, x times w, x times w, all the way down. It's a sum, so you see the pluses, right? We're adding, and then sum of the weights, okay? And so that gives us the GPA of 3.35. Well, what if we have a frequency distribution? You know, remember with the frequency distribution, we have all these classes, and then we're fitting our values into those classes. Is there a way to find the mean of a frequency distribution? And is that a little simpler to do than the regular mean? Because you could just take all your data and add them, divide by how much data you have, and that would give you a mean. But there's also a mean of a sampling distribution. I'm sorry, of a frequency distribution. And that's given by this formula. And this formula should look familiar. It should look a lot like the last one. Essentially, the frequencies are the whats? Well, they're the weights. Okay? Frequencies are the weights. Let's see how this works. So we've got these classes. This might look familiar. This is from our Laker data a few sections ago. And we have their frequencies. So what I want to do is find the midpoint, right? And if I'm just equipped with this information, I don't actually know what the actual scores are, right? I just know there are 2 scores in the 70s. One could be 71, one could be 79, one could be 78. Shoot, they both could be 74. I don't know what they are. Similarly for the other classes. So I'm going to pick the midpoint to serve as my data value. So the midpoint for this first class would be 74.5. And then 84.5. And you guys get the gist, right? 104.5. 114.5. 124.5. And 134.5. Okay. And so our mean of this frequency distribution will be the following sum. We have midpoint times frequency. So there's the first class midpoint times the frequency of that first class. Plus, then we move to the next class. Midpoint, 84.5. Frequency, 5. Plus, and we move to the next class. 94.5. Frequency, 6. Plus 104.5. Frequency 8. Plus 114.5. The frequency of 5. Plus 124.5 with a frequency of 3, plus 134.5 with a frequency of 1. And then grab your calculator and we can figure out what that is. So 74.5 times 2 plus 84.5 times 5. I encourage you to be doing this along with me. It's not pausing this. I'm on 104.5 now, times 8, plus 114.5 times 5, 124.5 times 3, finally 134.5 times 1. All right. So I'm getting a grand total of 3,055. And then we need to divide that by, oops, a little ahead of myself here. Divide all this by the sum of the frequencies. So the frequencies, let's just count those. 7, 13, 21. Oh yeah, we had 30 of these. So divided by 30. So let's see what we get. 101.8. Now, really, this, right? But because the rounding rule, I'm going to call this 101.8. So that's my mean, okay? Again, notice I don't know what the individual values are, right? That information isn't in this frequency distribution. All I know is the frequencies for the classes. So if we don't know the individual data values, we pick the midpoint, and then we just say, hey, whatever the frequency is, let's say we have that many midpoints. All right. So that sums up measures of center, right? Again, we're trying to figure out what the best representative is for a set of data. Typically, we're going to look at the mean, the median, or the mode. We saw that the mean is appropriate when there aren't outliers. We saw that the median is highly resistant to outliers, so that's a good choice when you do have an outlier. And then the mode, when the data is pretty uniform, the mode seems like the natural choice. In the next section, we're going to turn our attention to variation. How do we quantify, once we know the measure of center, how different the data is from that measure of center? And there's a couple of ways to do that, and we're gonna look at that next. So until then.